T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.
Giant $10 billion telescope is heading deep into space. James Webb Giant Telescope, a giant astronomical observatory, which took about 20 years to build and cost about $10 billion, is preparing to launch into space. To be the human eye capable of revealing the deepest secrets of the universe, will we discover alien creatures soon? Humans' quest to discover the deep secrets of the universe has continued uninterruptedly since the success of the Russians and Americans in reaching the moon more than 6 decades ago. And recently the conflict between the major powers moved from Earth to the sky, amid fears of the militarization of space. But within days, a giant astronomical observatory, unprecedented in its size and advanced technology, will make its way to the sky to take its place behind the moon and begin to observe the deep universe and provide a clear and detailed picture of the secrets of that universe for the first time in human history. When does the giant telescope mission begin? Later this month, humans may enter a new world of the secrets of the universe. On Wednesday, December 22, astronomers will launch the largest and most advanced astronomical observatory known to mankind. The observatory bears the name James Webb Space Telescope, after the second president of NASA, who was head of the agency under Presidents John F. Kennedy and Lyndon Johnson. It took 2 decades to establish the giant astronomical observatory and cost $9.69 billion, but it will change our perception of the universe and the beginning of our existence. And perhaps the nature of our search for life itself. Participating in the telescope project, the U.S. Space Agency, NASA, the European Space Agency, ESA, and the Canadian Space Agency, which is equipped with a gold-plated beryllium hexagonal mirror with a diameter of 6.5 meters, collects more light than any other space telescope. All of this means providing a view of the sky in a way that humans have not had before, from galaxies and planets to the birth of the universe itself. We've built a spacetime machine, says Mark McGreen, ESA's senior science and exploration advisor. Work on this telescope began since the mid-90s, after NASA had launched the Hubble Space Telescope in 1990, which in itself was a revolution in our cosmic knowledge. But astronomers kept dreaming of the next step after that. The question was, could something much greater in design and ambition be unleashed at the turn of the 21st century? Something that would surpass the Hubble telescope and reveal the deepest mysteries of the universe. Why was it delayed 10 years? The James Webb Telescope came to meet that ambition, and was scheduled to launch in 2011 at a fraction of its current cost, but the project has suffered several delays and budget overruns. However, it is not down to mismanagement, but rather how much technological leap this telescope has taken in its design. We built a dream, says ESA's McGreen. We may have underestimated the difficulty of building that dream, but in the end we made it happen. Altogether, tens of thousands of people have worked on the project. The initial plan was to move the telescope from its construction site in California to its launch site in French Guiana, on the northeastern coast of South America. But the telescope was too heavy to carry over 90 kilometers of unstable roads from the airport to the launch site. Then, in October, the telescope was shipped through the Panama Canal and then across the Kourou River in French Guiana, which was smoothed so that nothing would get in the way of the ship and its heavy cargo. The timing of the flight has been kept secret to guard against pirates. From Guyana, the telescope will launch into space and fly for more than 30 days to a place about 1.6 million kilometers from our planet, far from our sun. Beyond the moon in a region called the Lagrange Point 2, or L2, where the gravity of the sun and Earth cancel each other, allowing the telescope stay in place. On the way, the telescope unfolds 18 pieces of gold-plated hexagonal mirrors, forming its giant mirror in a hexagonal shape, which is shielded from the sun by a 5-layer shield the size of a tennis court and coated with Kapton, an insulating membrane of polyimide plastic that keeps temperatures below -220 degrees. The telescope also deploys its instruments and components during its journey, a predictably nerve-wracking period when hundreds of parts must move. and a failure in any of them could end the telescope's mission before it began. After that, the telescope will spend 5 months testing its instruments, before embarking on its great mission of observing the universe. The first images taken by the telescope will be shown to the public next summer. The new telescope will be able to observe the formation of planets around young stars, see beyond the dense layers of dust and gas that surround these objects, to watch the moments when these newly formed worlds take shape as they rotate, and may give us clues to how the Earth itself formed. The telescope monitors distant horizons as if it were a time machine, allowing scientists to go back to the first moments of the universe's life. And some of the light it collects would have been emitted by stars approximately 13.5 billion years ago, shortly after the Big Bang. Scientists are looking forward to examining these first stars that formed in the universe, inside the first galaxies. This reveals what these galaxies looked like and how they evolved, something that was not possible before. In our solar system, the telescope acts as a dancer's probe, swimming with its gold-plated lens along our solar orbit, capturing detailed images of planets such as Jupiter, Saturn, Uranus and Neptune. It is looking for ice models in a region of the outer solar system called the Kuiper Belt. And the telescope may be able to peek into asteroids and comets from other solar systems passing through our solar system.